Hello folks, Mr. Johnston back here again, and this time we're going to be talking about linear models, a little bit of linear regression, and, well, trying to find trend lines and make predictions. So what we're going to do is we're going to take some data and we're going to come up with some information based off it. Tonight you are going to be, or this afternoon, depending on when you're doing this, you're going to be working on linear modeling of gas prices, which is a worksheet, and hopefully we will have a chance to do that. Now, you will need your graphing calculator in order to do this stuff today, so hopefully if you've not got it handy, you can pause this, go back, see where you can get to, or if you've got yours being MIA, I have a separate video for doing much of the same stuff using Desmos, which will be good for right now, but you need to get yourself a graphing calculator. So let's get rolling. First off, I need to brush up on a couple things here, just to top on a couple topics that I'm hoping people are remembering from last year. First off, what is the slope formula? Well, remember, it's going to be y2 minus y1 over x2 minus x1 there. I have no idea why it's doing that strange thing. There you go. And next, I'm trying to find the point slope form. And on this one, what I can do is I can say, well, point slope form is going to be just y minus y1 equals the slope times x minus x1. Now, for those of you that may remember this from last year, you remember that all you're doing is you're taking the slope that you just found by using the slope formula, and then you're taking one of the points, x1 and y1, you substitute the x in here, you substitute the y in there, and now you're in point slope form. And then when you distribute the m to both of those, and then add y1 to both sides, what you end up coming up with is the slope-intercept form. Again, the slope-intercept form is the one that we can put into the calculator, and also is the one we're most familiar with. So let's get rolling here. First topic we're going to be discussing very briefly is going to be the concept of a trend line. Now, a trend line is a line that passes through the data, and by passing through the data, it kind of models what's happening there using one equation, as opposed to I could have multiple lines there, but it's what we're kind of finding is the most appropriate line. Now, a trend line that gives the most accurate model, we call it the line of best fit, or sometimes the regression line. Normally, we would go through the whole process of finding and writing the equation of a trend line. We'd go through and actually make a scatter plot. Then we'd sketch the best trend line that we could. Then we'd choose 2 points that we found on the line, and then we'd go through using the equations that I just got done with to come up with an equation in slope-intercept form. And then we finally get down to the part that's actually powerful, which is using the equations to make predictions. Because, well, that's why math is useful to the rest of the world, is it can actually do things that otherwise you wouldn't be able to find out. Now, I just want to emphasize, though, we're in the middle of COVID, so we're kind of condensing this a little bit. The trend line that gives the most accurate model is what is called the line of best fit, or in some cases it's called the regression line. And since we're doing this for a line, we're going to talk about linear regression. Again, linear regression here. So let's get started on our situation and see what we can do. Now, this is a table that shows the percentage of U.S. households with internet access. Now, again, please understand this is slightly dated data. I get it. But that being said, it doesn't mean it's completely useless. Now, again, we've been reading data for years. But how can they make things a little bit more interesting or possibly more challenging to you? Well, when they ask you to use it, they will generally include some sort of caveat like this in there, where we say, let X be the number of years since 1995. And if you just breeze through and said, oh, there's my stuff, I'm going to just do what it's there, that's going to mess up your graph. So what we're going to do is we need to take this information and use it to convert this into the form that they want it to be in. So here we go. I'm going to say I'm not supposed to use the year. I'm supposed to say that my X coordinate does represent years, but it's years after 1995. So what that means is 1997 is 2 years after, 2000 is 5 years after, 2001 is going to be 6 years after, and let's see, we're looking at 8, and then I'm looking at 12 here. So I am now going to say that I don't want to have that involved. Now, please understand that, once again, if we are doing this by hand, one of the things that's really critical to make sure that everybody understands what you're doing is you want to take the time to label your axes. So I'd say that that's going to be year, and this is going to be percent. And we go through and find things. Now, again, this is COVID, so we are now going to be messing with doing things on the graphing calculator. So once again, if you've not gotten your graphing calculator, please pull it out and we will start working with that. So here's my graphing calculator. I happen to have it handy. And so what I want to do is I want to get it so that I can actually enter my data. Now, how do I go about doing that? Well, I am going to push the buttons on the calculator that'll get me to the screen where I can enter stuff. That's going to be under Stat, okay, Statistical Analysis. So I look here for my red button that says Stat. You should find it next to your direction wheel. And now, to enter the information, that's called editing something. So I'm just going to say, all right, that's what I'm looking for. So you can either push 1 or enter. I tend to like to push the number, so I'm going 1 there. The problem is I've already got some data here. Now, many of you never have done this, so you have no data there. Well, how do you get rid of the data? All I need to do is just highlight something I want to get rid of and click on Delete, Enter. So I'm now going to delete this and delete that, delete that, delete, delete, delete. And now I'm ready to enter my data. Now, again, notice I am going back to the data that I've adjusted my years. So I'm going to say it's going to be 2, then 5. Whoops. Apparently it didn't take the enter. There you go. 2, 5, 6, 8, and 12. Now I've entered my x coordinates. Now let's go about pulling back and getting your y coordinates. So I'm looking at 18, 41.5, 50.4, 54.7. Whoops, didn't take it. 54.7. Got it. And then 61.7. Okay, and now I hit enter. Now, when it comes to doing the calculation of your line of best fit, there's a built-in function for the calculator to do that. But I do want to show you something else also, because some of you guys really would like to see what you've created here. And you can actually do a scatter plot using your graphing calculator. What I would like you to do is push the y equals key. And I am now going to go up there and plot 1. If it is not highlighted, go up to that, highlight it, and then push enter, and now it's lit up. And you can also have the calculator tell you, well, I can find where on the graph things would look best. So I'm going to hit zoom, and since I entered them in the statistics button, I'm going to push 9 for zoom stat, and it creates a really nice scatter plot for me. Cool. All right, now let's do about coming up with the line of best fit. How do I do that? I'm going to go back into, and by the way, notice I went second mode, which is quitting, going back to my home screen. I'm going to go into stat, and I am looking to do a calculation. So I'm assuming people are not going to be surprised when I push the right arrow over to highlight this column, and I can say, well, linear regression, linear regression. It actually appears twice on here, but I'm going to take the first one, which is 4, and it pulls up this screen. Now it's already got the information entered. It's kind of preloaded and it says, okay, you want me to use y1 as your x coordinate? Yes, I do. You want me to use y2 as the y coordinate? Yes, I do. But I also wanted you to enter one more thing, because my guess is many of you, the process of doing the regression and then having to transfer it, put it down on your paper, and then copy it back in so I can get something that looks like it on my graph. It would be really nice if the TI-84 would do that automatically, and it does. So what I'm going to do is, once I've got it down to the line where it says store reg EQ, I did that by hitting the down arrow. Now I'm going to push alpha, trace. And what this does is it's a shortcut that pulls up an option that'll allow me to just import it into y1. So I push 1, and now I push calculate, and there is my linear regression. Now, I will tell you, in many of your classes, you have been going to 2 decimal places. I would like in this class for you to start going to 3 decimal places because SAT and AP really like 3 decimal places for some reason. So carry 3 decimal places as we're doing the work on this. And you might remember I said it would be nice if they imported it. As a matter of fact, hit y equals and you can see they've imported it, and not just to 3 decimal places, they've included actually more than we even displayed on the screen. So this is going to be a very, very accurate graph. And by the way, if I want to see what it looks like and see how my line of best fit goes, I'm going to push graph. It's still in the zoom stat mode and looks like it's going through the middle of the data very nicely. So I'm ready to get some questions answered, and I'm going to go back to my document here, and I'm going to say, all right, it said to use my graphing calculator to determine the equation of the line of best fit. And at this point, I'm hoping that you guys can copy that down there because that's what it should be looking like. Okay, let's answer a couple more questions. Okay, describe what the scatter plot reveals about the relationship between years and percentage of households. Now, using our language from yesterday, not too hard, you're going to say, well, let's see, it was fairly close to the line, so it's a strong correlation. And then it looked like it was, as my x's increased, my y's increased. So I'm going to say it's a strong positive correlation. And you're going to say, yes, that's got it. Now you might notice once again, we've got more language here. This is not for the math purposes, this is for the application. The business people in Illinois have really pushed us to make sure that we are making you guys explain what things mean. So I'm going to say, as the numbers of years increase, again, remember the number of years was my x coordinate. So as the number of years increase, the percent of U.S. households with internet access increase. So basically, they're asking you to write this out. Sorry, not my choice. Blame the business people. Anyway, so here we go. Interpret the slope and the y-intercept of the trend line in the context of this problem. Okay, I can do that. The slope means that since we're talking about, again, you might remember that slope was my change in my y over my change in my x. Well, what was y? Well, if you remember, y was my percent of households with internet. Okay? And then my x were my number of years. So I'm going to come back here and I can say that the slope means that there is roughly and I'm going to say, let's go 4.172% increase in households that have internet access every year. Okay. They're also going to ask for interpretation about the y-intercept. So that means that in year 0, which is what my y-intercept is, we had approximately 17.722% of U.S. households had internet access back in 1995. Once again, please take note, this was in 1995 because I took my X of year 0 and converted it back into the language that everybody else is using. Okay, so next up, we are now going to be doing stuff with this. And we're now looking to use the equation of the trend line to predict the percent of households with internet access in 2020. Now, how would I do that? Well, we're going to still take that same equation that we had before, and we're going to say, how do I pull that in? Well, I'm going to be saying that y equals 4.172x plus 17.722. And I need to turn this into something useful. I'm going to say, well, wait a second, 2020. Can I just plug 2020 in for the number of years? Be careful, folks. Remember, we never used 2020. As a matter of fact, we didn't use 1995. We had to convert these into the number of years after 1995. So my X value that I'm actually working with here is 25 years. So what can I do there? Well, I can pull up my graphing calculator and I can say, let's go 4 point, let's see, it was 172 times 25 years plus 17.722. And I can now enter that and I can say, all right, then that means, according to my equation, that, let's see here, 122 point, I'm trying to remember, what was that, 122.022. So 0.022% of households will have internet access. Does that make any sense? No, of course not. Well, maybe something's gone wrong. Do me a favor, let's go back to the graph. Take a look here, folks. Does it kind of make sense that even though I drew a line here, that probably a better estimation would be a curve? And maybe that would be the better way to model this situation? Well, since that's the case, we're just doing an approximation here, and we're going to be okay with that. Okay, so it's not perfect, but we'll make do best we can with that. So, and let's see if we got anything else. Ooh, we've got one equation, and I'm going to try and take a couple minutes to go through this. Next, based off of the line of best fit, which I'm hoping we still have available here, I am looking at y equals 4.172. That sounds like my neighbor's dog is barking. Okay, and then plus 17.722. That's my line of best fit. And it's asking me to then predict when I am going to have 80% of my households to have internet access. Okay, now I'm hoping folks remember that this was years. This was percentage. So if I'm going to do any substitution, it needs to go in for y. Well, let's see what happens. And I plug in 80% here. Okay. Got it. And now what can I do about solving this equation? Well, let's take 80 minus 17.722, and that's going to get me 62.278. Okay. And then we're going to divide through by 4.172, which gets me an X value of 14.928. Okay, so cool, I'm done. No. Why not? Because that's the year when I'm expecting to have 18% or 80% of the households to have internet access. Yeah. Oh, wait, remember, we have to turn this back into an actual year, which in this case means it's years after 1990. So what I'm going to do is I'm going to take that value and I'm going to add that to 1995, which is going to get me up to an answer of 2009.92. So if as a businessman I was asking for when is it going to occur, I'm going to say at the very end of 2009. Okay, so that's it for today, folks. Thanks very much for playing, and go ahead and see what you can do on this worksheet, and I'll see you in class. Take care, have fun. Adios.